Alright guys, so here's that book that we didn't get filled out in class. So if you want to do this for extra practice, you could. If you're fine, you can turn the video off now. So we talked about being one-to-one, and a function and its inverse is one-to-one if it can pass the vertical line test and the horizontal line test. Now I said pass the vertical line test for both, but that's kind of the same deal. So if you just want to think about the function itself and think, would it pass a vertical line test and a horizontal line test, that's maybe a quicker way to tell that it's one-to-one. So if it can do both. Alright, so the first sort of example that we had here is if we were setting up a table that maybe I need to graph or whatever, then if I have x comma y points on our OG function, then y comma x, or just the swap of the two, would be on the graph of our inverse function. So if you're looking at those first examples that you have on your homework, you have your original function table, which isn't even all the way plugged in, and then you also have your inverse function. But if you take a look right here, this first point was fully filled in on both, and they're just swapped. So when I look at that next one, when I had -3 comma -9, here I'll have -9 comma -3, so we just swapped. It's safe to assume that these all go in order, so this next one where I was missing x comma -15, this one would have to be with it. So this has to be 1, and this has to be -15. The next one, we'd have 5 comma something, and here it's showing you that it was 17, and so that would be 5. And then the last one would have to be 33 because of the swapping. Okay, so same idea over here. Assuming that these points just all go in order, and we got 1 comma 1, 1 comma 1, then this first one should have been 0 comma 10 because we have the 0 over here, so 10 comma 0. This must have been 2 comma -2 because we have the -2 over there, which would be comma 2. I don't really know what happened here. I think I forgot to put a number, but that would be 4, and this would be 10, so we can just zoop that right out of there. Although, chances are it was probably a 3, because it seems to be going in order. And if that was 3, then this was 3. The bigger question is, like, what would that have been? I don't know. If you notice a pattern, let me know tomorrow. Okay. On the next ones, if we're taking a look at the graph, we said we could use a table and just plot all the points. But we also talked about how it was a reflection over the line y equals x, which is just that line that goes through the origin with the slope of 1. And so, like, if you had something like trace paper at home, you could just trace over this and then flip it over, put it on the other side. But what we were doing was we were kind of just plotting the points by swapping them. So like this first one here is at -2 comma 3, so I would put it at 3, -2. This one is at -1, 1, so I would go to 1, -1. And then this point here, the last point was at 1 comma -3, so -3 comma 1. And then we would connect our new dots. The two lines should cross each other right on your reflection line, and hopefully it feels like it just got flipped over to you. Okay, so similarly here I could take each of these points and swap their x and y to plot my inverse points. So this is at -1, -2, so we're going to be at -2, -1. This point here is at 2 comma -1, so we're going to be at -1, 2. And then this point here is at 3 comma 1, so we're at 1 comma 3. And then for me, I'm like turning my body, but sometimes you can turn your paper to make sure that you mirror this out correctly and get those curves kind of how they're supposed to be curving. And then they want to cross right on that line. My God, I'm amazing. Sorry. Yeah, it looks pretty good. Okay, last one. So when we're dealing with equations, the mathier way to do it is to swap your x and y and solve for y. So on this one here, I'd rewrite this as x equals half y to the third plus 4, and then just work on getting y alone. So I'd subtract 4 both sides. Then I would get rid of the half by multiplying everything by 2. So 2x minus 8. equals y to the third. Then I'd cube root the whole thing. So then you have y alone, which means your inverse function is cube root 2x minus 8. Okay, same idea on B. I'd swap x and y, so we'd have x equals square root of 6y minus 4. The first thing I have to do there to get y alone, girl, hush.
Could you please repeat it?
Siri's listening to me again. So I'd square both sides, so we'd have x squared equals, and over here they cancel out. Then I would add 4 to both sides to get y alone. So we're going to have x squared plus 4 equals 6y, and then divide everything by 6. And so you can do big divide bar, or you can do each one over 6. I'm going to leave it big divide bar, so you got your inverse function is x squared plus 4 all over 6. Now when I think about it, this one is a function, and that one is, because this is like that slow dab, Debola looking thing. And then this one here is your parabola looking thing, so this would be 1-to-1. If that's something that you're thinking about. And I just kind of think about what the graphs look like to tell if they're 1-to-1. Okay, so last but not least, I would swap my x and y. So x equals y squared minus 4. I'd add the 4 to both sides. And then to get y alone, you have to square root. And whenever we square root while we're solving, we always put that plus or minus. So we get our inverse function this time is plus and minus root x plus 4, which this first one was a parabola, which is fine, but now the second one is a sideways parabola because it has the positive part and the negative part, and that would not pass, so it's not 1-to-1. Oh my god, I was supposed to be doing that anyways. Oh my gosh. Well, back to the first one. That one is 1-to-1. Passed both tests, so. Oh my gosh, good luck. I hope you're going to do amazing. I know you're going to do amazing. That was longer than I intended.